Okay, so folks, the whole test paper I've made for you for iteration and recursion is in the description on this video, so have a look at the description. I'm now going to do task 1, A and B, well, question A and B to begin with. Alright, so I'm going to make a function, I'm going to call it iterative, did it give us a name of a function? Yeah, iterative sum of events, spelled, or even. Let's look at the question itself. What is it that I need to do? Take a list of integers and return the sum of just the even numbers. Okay, so I'm going to need a local variable. This local variable is going to be called total. I'm going to save it as, or assign it 0. I'm going to need an array. I'm going to call it numbers equals 1, 2, 4, 5, 6, 8, 9, 10. I'm going to pass in numbers. I'm going to loop through numbers. I'm going to check whether or not each number is divisible by, well, if it's an even number. So if numbers I mod 2 is 0. We're basically saying it's an even number. If we mod it by 2 and there's no remainder, it's even. So total equals total plus numbers I. Return total. Let's result equals iterative sum of events. Evens in. Why am I keep saying events? Print result. So let's run the code. – 30. Let's just double check that. 10 plus 8 is 18, plus 6 plus 4, 28, 30. Okay, perfect. What next do we have to do? Okay, so what we're going to do now is we're going to write the same code again, but using recursion instead. So how will I go about this? Well, I'm going to use the same numbers. So I'm going to do def recursive sum of evens. But this time, let me just comment out this. I'm going to pass in the following things. We're going to need a variable which keeps track of how many times we've looped. So like an index or a count. Let's do count. We're going to need a variable which stores the total. And the reason why I'm passing these into here, we could set it locally, I suppose, but the problem is if we set it locally, it resets every time it runs. So if we were to do this, numbers, and we do total equals 0, and remember with recursion, we call itself. And let's put in total here. It's going to basically reset it back to 0 again. So we can't put it as a local variable. So therefore we're going to pass it in. We're going to pass in a count and we're going to pass in a total. And we need to create our base case. When do we want this to stop? We want this to stop simply when we've looped through the list of numbers. So if count equals the length of numbers, return whatever total we've calculated. That's when we're going to stop. Otherwise, if numbers count mod 2 equals 0, what we're going to do is we're going to take our total equals total plus numbers count, so the same as before. And then we need to do our base case, to call it again. So we're going to do a return recursive, recursive sum of evens. And we're going to pass in numbers. We want count to go up by 1, so count plus 1. And then we're going to do our total. And if we go to chorus, result equals, because of sum of evens, and we're going to pass in numbers, index, so count even, and total. And then we're going to print results. So it should give us 30 again, if we've done this correctly. So I'm going to run the code. And there we go. So what's happening behind the scenes? So all the work for this happens in the winding phase in terms of the calculation. So if we trace this through, we pass in all the numbers in our list, 0, 0 to begin with, 0 for count, 0 for total. We check basically, so index is 0, that is 0, we check number 1. Number 1 is 1 itself. We don't do anything with that because 1 is not an even number. We then work with position 1, which is now 2. We check that number. And because that is an even number, we add that to our total. So 2 is our total. We then loop again. We check the next number, which is 4. And we're going to add that to our 2. So it's going to be 6. And it's going to keep going until we get to the end of our list, which is now going to give us 30 as our total. Now we then have to, once we get to here, simply return the total, which is 30. So all the work has been done already. So therefore, when we're unwinding, you'll notice it's simply returning 30 each time we go back through our stack. So it's almost as if what's happening is it's doing our totals onto a stack. So let's just draw it out. We're going to have on our stack 2, well actually it's going to be 0, 0. In fact, the stack will go the other way around, I'm sorry. So it's going to be here 0, then 0, then 2, then 6, then 6, then 12, then 20, then 20, then 30. When we unwind, we take so we get to the base case and we're going to take the 30 and we're simply going to return that each time. So my point being is that there's nothing really happening in our unwinding. We've already got to our total, so it's going to unwind our stack. Each time it's going to display, well, return the total until we get to the base case. When we get to the base case, this will be our final total, which is going to be displayed as 30. The next little question, I want you to give it a full go yourself first. This is a recap on winding and unwinding, where we do have different results when we're winding to when we're unwinding, because we're using an output in the code. Have a look at it, give it a go yourself first. It is a recap. If I change it to 4 and we run it. So how does this work? So the concept of how recursion works is it uses stacks. So I'm going to show you how a stack basically operates to perform this bad boy here, to give us, if we were to send in 5, to output 120. How this actually works. How do we trace it through? So we're going to start, by the way, I've just changed this to FR because it's quick for me to write than factorial recursive. Being lazy. So we've got our initial core. And our initial core is I'm going to pass in 5. So it's going to be FR 5. And that is basically 5 multiplied by FR4. So FR, one word, 4. And that would be our first node, you can argue, onto a stack, or first element on our stack. So that's our initial call. Then what's going to happen is the following. Let's redraw our stack, but this time it's going to be at the top of our stack, our next one, which is fr4. So we're calling fr, we're passing in 4, and it's going to be 4 multiplied by fr3. Underneath it in our stack will still be fr5, 5 times fr4. Remember, a stack is last in, first out. So when we push an item, it goes to the top. So we're going to push our next item onto our stack, which is going to be fr3, which will be 3 multiplied by fr2. Underneath that, we're going to have fr4, which is 4 multiplied by fr3. And then we have our initial function call, which is fr5, which is 5 multiplied by fr4. And then we do it again. fr2, which is basically, I really hate writing, 2 multiplied by, that's a 2 by the way, fr1. And then we've got our fr3, 3 multiplied by fr2. Then we've got our fr4, which is 4 multiplied by fr3. And then we've got our initial call, which is fr5, which is 5 multiplied by fr4. Okay, that leaves us with our final one, which is going to be our base case. So that'll be fr1. But we're not going to be doing anything else apart from return our base case, which is 1. Then you'll have our fr2. You know what? I must be able to copy and paste this. I can't be bothered to keep doing this. Do. Oh. You know what? I need to get better software. If anyone knows any better software out there that I can use, that would be amazing. Hello, I just said duplicate. Oh yeah, I forgot you don't like doing that. Duplicate, let's do it this way. There you go, nice sheet. Okay, so we call this concept winding, where we're just basically pushing our function calls onto the stack. But we're not done. We now need to unwind the stack. I'm going to do that on the next whiteboard. So what we're going to do now is we're going to actually pop from our stack. We're going to unwind. So how's that going to work? Well, let me just draw a line here. We take our first element, which is our base case. So it's actually it's fr, isn't it? fr1, and we know that we're returning 1, so it returns 1. We're then going to do fr2. So we take the 1 and we take the 2, so inside of this it'll be 2 multiplied by 1, which is now going to return for us 2. So this is one element, this is another element. We're now going to do fr3, which is going to take r3 and multiply it by 2, and it's going to return 6. But we're still in the stack, so it's not over yet. We're now going to do fr4. Our fr4 is going to take r4 and multiply it by 6, and it's going to return 24. We then got fr5, which is going to take 5, oops, and multiply it by 24. And that will return 120. This is the basically now top of our stack. There's no more elements after it. So 120 is the final result. So what we had to do was wind and unwind. Let me show you how this looks like in a table format. And let's bring it right back to over here. This is us adding to our stack. Keep in mind that this would be, by the end of this, the top of the stack once we wind. When we unwind, start on the top of the stack. This is what happens inside the function. This is what's returned. So now this has been popped. We're now onto this one. This is what happens inside the function, this calculation. This is what's returned. It's been popped. In memory is 2. We then do this one and pop it, and do this one. And remember, every time we pop, the top of stack will go down. So now we'll be here, top of stack, the final one. Pop, and this is our final result, 120. Okay, what I want you to do is turn this pseudocode into Python, and I want you to then call the function in Python using the following parameters. Pause the video, give it a go yourself. And if you did it correct, you should have 32, 1 and 0 as your output. Here's the code. So that is the code. What I'd like you to do now is see whether or not you can turn this into a trace table / stack. So you can show the process of winding and unwinding. I'm going to ask you to pause the video and then give it a go yourself first. So as a table, we normally have the core stack level as a column. That's just really neat. We then have the function core. Action and function. And output in this case, because there are some outputs, hence the print. Okay, so the first item we push onto our stack is going to be 15 and 10. In fact, I'm going to do 10 and 15 because I want to show you the result for that. So I'm going to call 10 and 15. So my function call would be, I'm going to do u for unknown. So my function is just called u. 10, 15. Action in the function. So what's going to happen? Well, 10 is less than 15. So we're going to print 10 plus 15. So it's going to output 25. I'm just going to put in here. Well, I don't really need this column. This is just for me to explain to you. So 10 is less than 15. So print the 25 because we do 10 plus 15. Two. So remember, we're winding at the moment. We're not returning anything. We're just winding it up. u. This time it's going to be 11 and 15. Why is it going to be 11 and 15? Well, I'm hoping that's going to be quite obvious. X plus 1. X was 10, now it's 11. 15, y stays the same. So action in the function, 11 is less than 15, so print. Remember, this is just like an optional column. I'm doing this to help demonstrate that we're doing this again. So we're going to print, and this time it's going to be 26. Why is it going to be 26? Because we are printing 11 plus 15 here. We're going to call 12 and 15 this time. 12 is less than 15. My toilet's making weird noises. I might go and check that out in a second. So 12 is less than 15. I don't know why I've just done that little line there. Oh, there you go. Okay, so 12 is less than 15. So what we're going to do is we're going to print, and this time we're going to print 27. Core U 13, 15. We're still winding at the moment. 13 is less than 15, so we're going to print 28. 5 U 14. That's meant to be a comma. Comma 15. 14 is less than 15, so we're going to, bear with me for a second, print, and I'm going to print 29. 6 U 15. 15. This is going to be different. 15 equals 15. If 15 equals 15, we're going to return 1. There's no output for this. It just returns 1. Now we're going to be, now that we've reached our base case, we are going to very simply start to unwind our stack. So our top of stack has been popped. Return 1. Oops, my bad. We should be now into 5. And we're going to call unknown 14, 15. And all we need to do now, because it's going to be this, what I've just marked up there, it's going to be 1 multiplied by, so that 1 multiplied 1 multiplied by, and it's going to be 2. So it's going to be the 1 multiplied by the 2. And that's going to return that as our calculation. So i.e. is going to return 2. So if I go down again, and I'll go on to 4. 4, it's going to be U 13, 15. And the action in the function is going to be the result of this, which is 2 multiplied by 2, because inside of here, that's what the return is, multiplied by 2. If it was this, it would be divided by 2. Well, div to get no remainder. I'm going to pause, there's something weird going on. Forget it. I'm going to call the plumber in a second. Anyway, so this is being returned, so it's going to be 4. So when we unwind again, and we're going to have U, I think it is obviously going to be 12, 15, and it's going to return this 4 multiplied by 2, which is going to be returned, which will give us 8. Keep that in mind, 8. So when we go to the next one, it's going to be 8 multiplied by 2, which is being returned, which is going to be 16. And finally, our top of stack, which is our original number, 10, 15, which was passed in, is going to be our 16 multiplied by 2, which is returned, which will give us 32. What I should have done, another column called return value. Yo, why are you not writing? There you go, return value. And then obviously there's no returns here because it's just outputs based on the code. But when we do unwind, I can put like 4 in here, 8 in here, 16 in here, 32 in here. And there we go. This would be the table. Well, we very simply, let me just make a differentiator to where we start unwinding. When we reach the base case, we can unwind. But I should put a 1 here as well, 2 here for our return values. Okay, let's make this a little bit harder. Turn this into its iterative version. So how would you do this code as a loop? Okay, so how did we come up with this? Well, first things first, we look at the base case. Return 1. Now, here's the thing. This will always happen. The base case will always happen in recursion. So it's always going to have in the code the result being 1, the total being a 1, whatever you want to call it. So as it always happens, we declare it first. Result equals 1. Now we look at our logic. We've got 3 different conditions within this code. This basically, this recursion keeps going until x equals y. So this will keep going over and over and over again until x equals y. So with our iterative version, we want to keep it looping whilst x doesn't equal y, which is what we've got here. Whilst x doesn't equal y, keep looping. You'll notice that both the else and this if both have the print x plus y, so it happens for both. So we put it here because it displays. If x doesn't equal y, then we print x plus y. It doesn't matter which way we go. But now we focus on this bit because this is where it is different. If x is less than y, what we want to do is make x go up by 1. That's one of the things which happens in this condition for this selection. X goes up by 1. But we've also got our result, which is what we're returning. So what we want to do with that is multiply it by 2. So result equals result multiplied by 2. Otherwise, take away 1 from x, and we basically get this variable called result, and we div it by 2. And so x will keep changing, y stays the same, which is what happens in here. Y stays the same all the way through. Y is the same, y is the same, so we don't need this to do anything. This would be our result, which is what we've got here. So result equals result multiplied by 2. and it loops again and again and again and again. So if we play this out, I'm not going to do the whole thing. We're passing in 10 and 15, 10 and 15, and we're going to make a variable called result in a table, and I'm going to do x, I'm going to do y. X is passed in. Okay, by doing all of this, hopefully we'll get to the same output as what we had before, and the same final return value. So let's trace this through. Result starts on 1. X is 10. This is 15. We then have 25. X then goes up, well, X is less than Y, so X goes up by 1. And we take our result, which is going to be 1 multiplied by 2, gives us 2. That loops again. We're then going to display X plus Y, which is 26. X goes up again to make it 12. Our result will be 2 times 2, which is 4. It then loops again, so it's going to be 27 here. 5, no, it's not 5, I'm an idiot. X goes up by 1, 13, 15, 28. 4 times 2 is 8. Then X goes, do we do X goes up? Yeah. Then, I think I did that in the wrong order. Yeah, I should have done that first and then output. So let's get back to this again. Okay, X goes up by 1, so it would be on 14, 15. Result would be 8 times 2, which is 16. And 14 plus 15 gives us 29. And then we're going to have the loops again. So we're still inside this loop. X plus 1 is 15, 15. Result equals 16 times 2, which is 32. It goes back to the start of the loop, but 15 equals 15, so it doesn't do anything else here. And it out returns result, which is 32. There you go. So a recap on how we turn this into the iterative version. Take the base case. The base case in this situation is going to return 1. So I assigned that. This is always going to happen at the beginning of our code. Always going to happen. Our condition is x equals y. So we want to keep repeating this whilst x doesn't equal y. This happens in both of our selection conditions, so we might as well just shove it here, print x plus y. This is the first thing which happens before it does any calculations. We then do our if statement if x is less than y. We then want to increment x by 1 because that happens if this condition works in the selection. And then what we want to do is take our result and multiply it by 2. Otherwise, divide it by 2. And remember, this should be, but this time minus 1. Minus 1. And there we go.